Hello YouTubers. This is the third video where we continue to talk about building enterprise level Blazor applications and using Blazor with C# 8, and very soon within that series we're going to work together into upgrading this to .NET 5 and using C# 9 and leveraging the great functionality that comes in with the new capabilities of Blazor once it's ready to go live. In the last video though, we talked about building brokers for our Blazor services. We talked about the horizontal data pipeline and the vertical data viewing pipeline, and how we need a broker and a service and a view service. And then, but you also want the pages and the components and the base components. So let's go back to where we started here, just to refresh your memory. The last time we talked about, okay, we have a core API that we want to talk to, and there are some brokers. And these brokers basically are going to be the liaison between whatever, technology you're using, whether you are posting towards an API or you're pushing towards an existing database, whatever your technology is that you're communicating with, the brokers in here are the ones responsible about, gluing your application to your actual business logic, internal business logic, to the outside world. You want to make sure, and this is very important, you want to make sure that whatever technologies you're trying to glue in here doesn't leak into your services. And by leakage, I mean, models, native models to some, NuGet library that you're using, or you want to maintain nativity of some sort to your services. So whatever code goes into that service, you want to make sure that it is your code and your code alone, meaning that your code, I mean your code and your team's code, but not some external code that relies on external resources or libraries or whatever the case may be. Some people asked me the other day, they said, well, we want to use things like fluent validations, or, we want to use things that does some graphic stuff. I said that, well, in that case, you have two options. Either you build your own validations like we're doing in this video, or you push these down to a broker level and then consume those as an external resource. Either way you want to do it is fine with me, as long as you do not let your external resources leak into your business logic and control your world. Okay, with that being said, let's just jump in. We built brokers and we built a teeny tiny bit of services, right? Let's go back to our code here. OSSS portal. And I remember, because this is test driven and because we want to validate all of these things, you can see in here what we basically did. Let me increase the size in here for people that are on their mobile. I always forget this one. Let's put that at 200%. I hope that is good. 200%. Let me zoom out a teeny tiny bit. And then here's the screen. Okay, so everything now hopefully would be visible. So okay, we wrote some logic test, and we went in and said, okay, we are expecting that we're going to call the logging broker mock and the API broker mock, and that when we say register a student, then the input for that student should be in a particular shape and form. There's a little bit of validation that we need to add on top of that in order for this operation to go in smoothly, right? And I remember us writing a tiny bit of validation here. We said, okay, should throw validation exception on register if student is null and log it async. So if the incoming student object is completely null, then blow up and throw validation exception and say that's not okay. Now, with that being said, there's a couple of more validations that we really want to take care of while we are in this process. In order for us to handle these validations, in order for us to take care of these issues, let's just go ahead into this is our brokers in here. We're not talking to our brokers anymore. We have our students exceptions. We need to create a new exception in here. And this new exception will be called InvalidStudentException. And this invalid student exception is an inner exception, right? This inner exception is what actually specifically talks about the actual issue that happened, while you're trying to persist an entity or send an entity to an API. It obviously inherits from the overall exception model. And here's a little bit of, copyrights for the good-hearted engineers. And let's see what this guy actually entails. This guy basically has a constructor in here. If you type in ctor, it'll build a constructor for you. And we expect it to take in two things: a parameter name, the validation parameter name, and a parameter value. Right, so these are two things. And then underneath that, we could go and say invalid student error occurred, and then we want to tell people what happened. So let's take a new line in here and say parameter name, and then we can put a comma in here, and then we can go to another line and say parameter value. And let's do a little bit of string interpolation in here. So let's just go ahead and say in here, this is going to be like that. This is our string interpolation. Here's our parameter name, and here's our parameter value. So we need this exception. We really need this exception to indicate what kind of issues have happened while we're trying to push that student to the API. You don't want to pay the expense of going all the way to the API, finding out that your student object has some invalid data, and then coming back to your API, because that's costly. That operation is costly, especially if you're in a big enterprise application with hundreds of thousands of users. You don't want to pay that cost. That cost, adds up, and it might cost you quite a bit. Instead, we're going to do just this level of validation, but I want you to understand something. In here, in a Blazor application, you are actually doing, as long as you're not really communicating with the database, this is not your persistence layer, you're actually communicating with an API, it's good enough that you do structural validation. Structural validation means what? And I'm going to talk to you a little bit in detail about this, but for the most part, structural validation, let's step back for once here and just talk about this. Validations can come in three different shapes, right? When you're validating an object that's coming into your system, you are either validating it structurally, meaning that a string is not supposed to be null, or a string is not supposed to be empty or has white space. That's structural validation. That's the basic cable kind of validation that you do in any entity that you're trying to process, right? So this must exist everywhere, right? And then the second one is a logical validation. Logical validation, for instance, is when you're saying, okay, insert your date of birth, and someone entered a date of birth that is, in the year 1800 or the year 1300. That's a logical validation. You're basically saying this doesn't make sense. Even though the value is structurally correct, the value is structurally correct, but it's not logical. It doesn't make sense. So that's logical validation. The third one is a dependency reference validation. You have to go to an external dependency to validate a particular value. What's an example of that? If you're adding a student with, John Smith with the exact same date of birth and the exact same social security number, for instance, right? Then that's a dependency validation, meaning that this record already exists in the database, and therefore you are going to reject adding this entity into the database. So these are the three validations that you will find out there. I couldn't think of any other category for any validation out there that you would need, but for the purpose of building an external UI component that doesn't necessarily attach to the storage where you're actually going to persist this, and that this responsibility is being handled by another component, the best part for you is just to do the structural validation at the UI level. Obviously, feel free to add as many validations as you want, but you want to keep all your validation logic at one point. So if you have an API and you have a UI and these are two external components, you don't want to repeat the same logic of validation, especially if it's logical, because it's subject to change, right? Maybe some people will say, okay, we're going to migrate historical data from 200 years ago. Now your logical validation is starting to shake a little bit. Maybe they'll say, okay, we want to allow duplicate records, or we want to allow whatever you're using. You want to keep this in one single location when it comes to logical and dependency validation, but definitely the structural validation, which is obvious, it's very straightforward. It's just bare minimum validation. You're basically doing your due diligence on your application, that you're saying, I'm not sending you garbage data, but any logic that you have dependent on that, it's going to happen on your side. So let's go back to this guy here. now that we talked about validation, and this is like I said, these rules and these validations and these practices are across everything we're going to build, whether it's backend, API, front end, mobile, whatever you're doing, IoT, whatever application you're building, it's going to follow these exact same rules and it's going to follow these exact same concepts. So this is the exception that we want to throw when we find a validation issue for a particular entity, and it's just structural validation. Like I said, it's just structural validation. So this is this guy, and then we already have a student validation exception. So this is our inner exception, and this is our outer exception. Your inner exception talks about a specific deal, a specific story that's happening, and your outer exception is talking about the general category or realm where things fall apart. And like we talked before, you know, your outer exception can be one of four different exceptions. It's either a validation exception, something structurally is not correct. It's either a dependency validation exception, meaning that you're calling an external resource and the external resource is telling you something is wrong with your request. You don't want to mark this as validation exception, because if you did, what that basically means, it means that, you know, you have done the validation yourself and now you have the engineers that are trying to solve the problem spinning in circles, trying to look into each and every service instead of just following the trace until they find where the error actually happened. And then there is service exception, like we said, and there's dependency exception. You know, you're calling a URL that doesn't exist. Your authorization is failing. There is a 500 exception, some dependency issue that you have no hand in. You know exactly where to point the engineers to the right direction, tell them, look at this. This is not working. Something is wrong over there. All right, so we have the student validation. This is what we're going to be focusing on today, just the student validation exception. Let's validate a student. So this is the validation exception in valid student. So what I want to do here in my test, and I already have my validations in here, I'm going to write a test in here. I'm going to write a test, a bunch of tests, and this test is basically going to validate for particular values. Let's just go here and say fact, public async task should throw validation exception on register. So this is what should happen, where it should happen, when it should happen. There is a very specific order for how we name our tests. I very highly recommend you follow that particular pattern or standard so your code is maintainable. You know what it's doing. So we're basically saying should throw validation exception on register if student ID is invalid and log it async. So just in this one line, and this is the hardest thing when it comes to unit testing, right? How much words do you have? Like our limit is 120 characters. You want to fit in a description of what your method is actually doing within 120 characters. There's two reasons why we're doing this. It's 120 characters because if you have to do more than that, you're probably doing too much. It's not really single responsibility. And if your method is already doing too much, you probably want to break it apart into different cases. So the limitation of 120 characters does not just fall into the realm of it being readable and maintainable. It also tries to limit what you're trying to do and what you're trying to test into a very particular scope. There will be cases when you run into 121 characters and stuff like that. This is when you get to go play with words. Like instead of when, you use if, or if instead of student ID, you get to say if ID is invalid, knowing that within the context that we're working with, you know, the student is already, we know that the student has an ID and we know that we're talking about the student, so why not? If your method or your class is dealing with more than one entity at a time and it's not an orchestration service, you're probably doing something wrong. But this is why I do these videos, so you get to see these things and actually just explore for yourself. Not everything I say is necessarily the standard or the ultimate standard, but it's definitely things that worked for me in the last 20 years, and I really highly recommend that you take a look. How we break things apart, how we break our tests, we say given, when, then. So that's how we break our tests. And then let's create a bad ID. So let's go ahead and say invalid student ID. Right, and let's just go here and say GUID.empty, so we know that this is invalid. And then we're going to go create a student and just give it a bad ID. So here is a student, random student. Actually, let's call this invalid ID. It has nothing to do actually with the student, not just yet. The context here is still different. So let's go ahead and create random student. Here's our random student, and then student in here, and I'm going to call this invalid student. And this invalid student is going to take from random student, but I'm going to go and say invalid student.id equals invalid ID. So now I know that I have an invalid ID. Some people always ask me this question, say, Hassan, why don't you just say invalid student equals create random student? Well, what's the fun in that? You're not really telling the full story. You know, I see some people do random student, then they pass it in as input and they return it when they're trying to mimic an API response. That's really not a very good way of telling what your API is really trying to accomplish. That's not how you go about doing things. You want to tell the story. Okay, then declare another variable with a different name and let your code be more seamless and more readable. It'll take you 10 seconds, but it'll save you days of trying to figure out, or maybe hours of trying to figure out what your code is trying to do. What's the exceptions that we expect to come out of this? So, okay, so there's an invalid student exception that we expect. So new invalid student exception, and the parameter name of, watch this, student, so this is the model, and then ID. So this name of is one cool, real cool feature in C#. I think it was introduced either in 7 or 8. And the feature basically, instead of you, if at any point in time you decide to change the property name, you don't want to stringify this. You don't want to go and change this in 3,000 different locations. Some IDs are very generous. They say, hey, everywhere we find student ID, do you also want us to replace the strings as well? But that's just a lot of hassle, and it's prone to error. Instead, you could just say name of the class name.id, and that would just work fine. You could also do it by the property itself, but I don't recommend that. In case you have a dynamic object or whatever the case may be, it's not going to change, especially if you're mapping it. So here's the invalid ID. So why is it invalid? So this is invalid student .id. So this is the exception that I expect to come out of this. Did I mark this as object or did I say a string? This should be an object because we're going to pass in it all kinds of different things. This should be object. This is my bad. Let's go back here. This should be happy. So that's the inner exception. That's the issue. There's an invalid value that you passed in as an ID. That's not acceptable. And then the outer exception that's going to come out of this service to its neighboring services or the services that are calling dependent on it is expected student validation exception. So this is, student validation exception. And we're going to throw that guy into it, which is the invalid student exception, like this. Right? So we expect to identify the issue and give it a very specific exception that's very descriptive of what it's doing. And then there is this outer exception that says this is the expected exception. This is the communication, however you want to handle it. A lot of people have asked me this question. They said, why are you handling the exceptions on the service layer instead of just letting it propagate all the way upstream? There's many things that that play a role in that. Sometimes you want to log critical exactly when the exception happened. You don't want to go through your inner exceptions until you reach to the last one. And if you don't categorize your exceptions, that means you have to examine each and every type in your exceptions to determine whether to return a 200 exception or a 400 exception or a 500 exception. Right? So when you do it this way, it really helps. First of all, it containerizes your service. You can literally pluck your service out of your microservice or portal, wherever you're building your service, and put it in any other service, and you know full well that this service has a contract with you, that it's returning one of 4 exceptions, like we talked, or that the type and the input parameter. That's it. You don't have to worry about unexpected behaviors, weird things happening out of your service. You don't worry about that because it's already defining what the input is and what the output could be. It could be just the result, or it could be one of these 4 categories of exceptions, whatever the inner exceptions may be. So it helps you containerize and componentize your services in a way that makes them modular and useful, reusable, and pluggable. All right, we have all of that good stuff. Let's go ahead and execute. So in here, there's a value task, and we expect to return a student when we submit a student. But now we're not really going to return anything. We're actually going to return an exception, right? So how are we going to deal with that if we're going to return an exception? Then this doesn't become the actual student that's coming back. This is why I preceded it with value task. And now I'm saying a register student task. So this is not really what's going to happen, what's going to come back. This is just the task that actually executes the operation. And in here, I'm just going to go say in the student service register student async with an invalid student. like this. Well, what does that mean? It means that this guy wouldn't resolve yet. This guy didn't run yet. We're going to run it in the then section where we run it and actually expect an exception to come out of it. So what is the exception that we expect to come out of it? So easy. I'm going to go here and say await assert throws async. And here is your student validation exception, like this. And then I'm going to run it, actually. I'm going to say register student task. Obviously, because it doesn't know about the value task, I'm going to say as task. It's actually value task in here. But in here, this guy doesn't take input parameter as value task. It only takes a func of task. So until they upgrade the library, we're going to just say this is the task as task. So this now, now this guy is going to be running because you're awaiting and executing asynchronously, and you're expecting a student validation exception to come out of this guy. What else do we want to validate? We want to validate that we are logging that exception. So let's verify. Here's a broker log error. It is. So when you're logging errors, the reference of the exception that you're throwing in is not the same. It's not going to be the same. So we want to say same exception as, I think I talked about this the last time, which is our expected student validation exception. Let's break this apart a little bit because it's too long. We want to make this a little bit readable for people, and this should be called times once. So here's the deal. What I'm basically saying in here is that because I'm passing an invalid student, I expect an invalid student exception internally to be generated, and it will be wrapped with a validation exception. And when I kick this off, this validation exception will kick off, and I'm going to log this exception as it comes in. I'm going to log this exception as it comes in. All right, so this is great. Let's go ahead and say the last thing I want to validate here is that the API broker mock verify that this broker was never called at this operation with any student, right? So broker post student async, it is any student. So I'm basically saying here, no student ever has been called, has been passed in because of this invalid operation has happened. So this will be times never. This never ever have happened. All right, so calling a student post student asynchronously will never happen. The only thing that will happen is that we're going to log this exception with this particular detail. This is us engineering the edge cases, the errors, the exceptions, the bad things that could happen. So we are accounting for all things, not just happy path. Like I said in previous videos, anyone really could write a happy path end-to-end, pass the data across the API and show it. But the real engineering comes into the part where you're actually trying to account for the exceptions that will occur. All right, so this is the ID. We said this ID is bad and all that kind of stuff. And then at the end here, we want to go through all our mocks, and we're going to order them in the chronological order they were called or not called, right? So logging broker verify no other calls. We want to verify that no other calls have happened to this dependency. And also for the other mock, which is the API broker mock, verify no other calls. So if someone tries to sneak in additional calls to your dependencies, this test will fail. Actually, all of them will fail because they're basically saying someone is sneaking in code into your logic without writing test. So that's the beauty about this little teeny tiny verify no other call method. It helps protect your code. All right, so we have this guy here. Let's go ahead and do Control RT. As we are doing test-driven development, we need to fail and then need to pass and maybe need to refactor. Obviously, the refactoring thing, if you take your coding standard and guidelines to heart and actually commit to it religiously, you won't need to have that refactor step because you are writing beautiful code as you go. And because the code is very simple and single responsibility and it's not doing too much stuff, there won't be a lot of refactoring that needs to happen. If you actually follow truly religiously the principle of single responsibility, I promise you, you won't need to do a lot of refactoring because your code is just doing primitive operation or higher order operation or display. So you won't get into this really bulky, weird looking situation where you have, 50 lines of code method that doesn't necessarily need to be one method to do all of that stuff. So in here, okay, so it's basically saying I expected you to throw a validation exception, but you have thrown nothing, right? So what do we do then? We're gonna go ahead in here like a pure coding, purist approach, and we say this is a failing test. Step by step, very pure code. You're displaying the progress of how your code was written. All right, that's great. Let's make it pass. So if we go in here, what we really want to do is that inside that nice validate student method that we built, we want to start doing some more validations. Instead of if student is null, why don't we just do a switch case and do a pattern matching? So I'm passing in the student in here, and I'm going to go here and say case null. When it's null, throw null student exception. That's one case. Right, let's give this guy a scope. And this guy needs to be new null student exception like this. Great. That's one guy. The second guy would be when this student is actually an object. That's what this means, an object. So it's not null, it's an object. When this is the case, is invalid. And what is invalid? Student.id. But I haven't written yet the isInvalid method. Let's go and write it real quick. So private static because it doesn't really maintain any sort of state, and it doesn't call any class member. Therefore, it can be static. And then it returns a boolean, and we say is invalid. Is invalid. And then what are we passing here? A GUID. So this is an ID, and we're basically saying if this ID equals GUID.empty, then this ID is invalid. And under here, we're going to throw new invalid student exception with these parameters. Parameter name, name of student.id, and parameter value student.id. Here you go. So these are two things, right? So we went in here and we just refactored our method a teeny tiny bit. Instead of having it do one if statement, now we're adding rules. We're going to be adding a lot of rules to this one just to validate structurally what's going on. All right, so this is invalid, and this is the case in here. This is great. This is fantastic. Let's just go ahead and say, now that we're throwing this exception, now I need to go to my exception realm here and handle that. So I'm just going to copy this guy in here. I'm going to go and say every time you get an invalid student exception, please wrap it up in invalid student exception and pass it down to create and log validation exception. So this is our try-catch realm. It keeps our business logic clean and clear. If it's exceptions, then it needs to be on the side. It's something that you'll look at when you want to look into more details of how we handle these edge cases. Because this is not the edge cases, it's only displaying, it's artistic. It's showing you just the happy path. But if you really want to look more into it, then go ahead into this try-catch container wrapper that I built, and then inside of it we're going to handle all the kinds of operations with a delegate, and the delegate basically is just descriptive of what really needs to happen. Under here we just go and say, create and log validation exception. This is basically the case where we stand. Let's go back to our test again. Here's our test. Control minus will take you back to where you were. And here's our failing test, and let's run it again. You know what? While we're at it, let's run everything. Here is our test explorer. We have all of these tests. Let's run everything. Why not? Let's do everything. There you go. So that test now is passing because you're actually doing the proper validation to your student object. So this guy is green, again, because you're doing purist approach, which is going to go in here and say, okay, here's this test, and this test has passed. Okay, so this is done. Now, a lot of similar tests like these we're going to do. I'm going to do this really, really quick so you get to see this validation part and then explore this, and then there will be a couple of other sessions when we handle the API exceptions, and I'm going to talk to you about RESTful Sense API library that helps you understand and handle exceptions better, however they're coming from the API. So what else? What other validations we want to do with our student? If you look at your student object in here, we have quite a bit of things. We have a user ID, we have identity number, we have first name, middle name, last name. We have a bunch of dates, and yeah, that's pretty much. And we have a gender. We have a gender in here. So let's just go ahead and validate all of these because these are strings. And we are requiring, maybe the middle name is optional, we don't care about, but definitely the first name. Definitely the first name, because there are people in this world, and because we're building this system for people everywhere in the world, it's a schooling system. We're just gonna check for validation on the first name, because there are people in this world that actually have just a first name. They don't have middle name or last name. This is a reality. And I'm not talking about, famous people that have one name because that's how they're famous. No, this is actually the person's name. It's just one name, no family name, nothing at all. Therefore, because we want to be a little bit more inclusive, we're going to definitely go hard on the user ID and the identity number and the first name, but we're not going to validate anything in here. We're just going to let it slide. So we need to validate these three strings. And when you're validating strings structurally, you want to validate whether the string is null or empty or white space. So how do we go about doing something like that? Let's just go ahead in here into our tests, and let's write a test in here. It's going to be actually very similar to this. I'm going to steal this one. Check this one out. But instead of fact, I'm going to use something called theory. And theory basically examines the same test with different input parameters. So in here, I'm going to go and say, I think it's member inline data. So here's a null, and here's an empty string, and here's a white space, whatever that white space is. And now the last thing I want to do is that I want to go here and say this input parameter, invalid user ID. So this is the user ID. It can be null or empty or white space. And we want to change this guy. Instead of student ID, we're going to say if student user ID is invalid. Are we still at 120? Yeah, we are. And look at this. This is going to be very easy. Instead of generating this invalid ID, go ahead and take this invalid user ID and assign it to your user ID in here. And then go ahead and replace the student ID with user ID. Because it's still a validation exception, everything should just work like a charm, right? So this is the user ID validation, Control RT. Let's have this test fail for us real quick while I drink a sip of water. All right, and this guy is failing. Let's go ahead and commit. Always check to see whether you're failing for the right reasons or not. If you're not failing for the right reasons, you need to go back and don't underestimate that practice. A lot of people say, okay, yeah, let's just assume that it failed for the right reason. Don't assume things in programming. Assumption is bad. Don't assume anything in programming. So this is just it trying with different input parameters. It will even show you, if you hover over, you can see at that tooltip, that it says null, empty, and empty string, and no string at all. All right, so let's commit this guy in. So this guy fail. And then let's go into register student async. If you do right click implementation, and then go into validate student, we just need to add this one more thing. We need a method in here that also says invalid. It makes your code look a lot cleaner without having to look into details. A lot of people say invalid ID is invalid string. Don't do that. You just want to know at the higher level that it's not in good shape, right? And then empty or is null or empty. I think it's empty or white space. Is empty or white space is null or white space, and that will take care of all the cases for some reason. It would be nice if this method was called is null or empty or white space, but apparently it takes care of it. Like white space takes care of a string that's an empty string. All right, all we have to do is just copy this guy here. It's just another rule that we're going to throw in. And this guy is going to be the student user ID. And this is the user ID. And this here is the user ID. Now our test should just pass, should just go like a charm. Let's see if that works. Let's go all the way back here, and here's our test, control minus. Let's run this guy again. There you go. Pass, right? It examined it with all these different values, and it just passed. Great. Let's take this guy here, and let's Put it in here and just say pass. Great. Now we have 3 more of these, right? We have 3 more of these. Let's do the second one real quick. So here's another theory. Here's the test. I can go here and say now that identity, invalid identity, right? So this is if user identity, and that's for external identities for schools that want to have additional identity other than the login identity. And then this is identity number. We say it's an identity number, but the reality of the situation is that an identity number in some places around the world could be A1Z, 0123, and they call this identity number. It's not really fully a number, and that's why we kept it into the level of keeping it as in a string format. All right, so this is the identity situation. Let's run this and see it fail. See, fail, pass, fail, pass, fail, pass. Sometimes a little bit of refactoring here and there, but that's pretty much all the validations we have to do. Here we go. So this guy is failing. Let's see if it's failing for the right reasons. Always, always, always check. There you go. It's failing for the wrong reasons, for failing for the right reasons. And then here's a fail, like this. And then let's go back and add a couple of more validations. I'm going to walk you through this even though there's some redundant activity, because I want you to see this being built from scratch. I'm not going to go turn off the camera and just go do some magic behind the scenes. No, you're going to be seeing the entire process of building this end to end. I also highly recommend that you look at the videos that I post about actually building the API. We just very recently upgraded our API. By the time of this video, we have already upgraded OSSS backend service into .NET 5. So I really highly recommend you go and watch the video and see how we upgraded from 3.1 to ASP.NET Core 5 with Entity Framework 5 and enabling OData and all that kind of good stuff. All right, identity number right here. Let's go back to our test and run it again. Control RT. And we have a passing test. Great. And then, like I said, it's just the first name that we're going to validate. We're not going to do anything with the middle name and last name, because as global and diverse this application may be, we don't want to actually enforce some rules that are not inclusive enough. So we're going to go out here and say this is a theory. Here we go. And then in this case would be invalid name, invalid first name. Like this, and this is instead of if student user identity, we're just going to say first name. First name is invalid and still a string. And let's take this guy here, and this is first name, and we're just going to replace these values. All right, let's fail again. Let's fail together. Let's fail all at once, all of us. Let's fail for good. Here we go. All right, so this guy is failing. It's failing again for the reasons in here. And let's just go ahead and make it pass. Let's commit this first. I'm going to show you the commit history of this. You're going to love it. In here like this, and I'm going to say fail. And then I'm going to go and make this pass. So here's a register student, implementation, validate student, and is invalid. Now we're just going to do the first name. So your first name cannot be an empty string. It can be null, and it can't be a white space. So this first name, and first name. Does that make our test pass? I don't know. Let's find out. Control RT. Here we go. Here we go. So this guy is in good shape. Let's make sure that our code is in good shape. So here's this guy, commit, and then pass. All right, so what else is left out there to validate a student? There's a couple more properties that we want to take a look at. So the first one here, the gender, if you are, and this is something I learned very recently from my friend Shimmy. He basically proposed validating a enums, especially on the API side. Okay, you can actually post a bad enum as a number because APIs don't understand this. You can actually enforce it, to be in its string value, maybe. But if someone is passing it in its native value, is passing you a 10, and your enum also has 4 values, 0, 1, 2 to 3, your API actually will be totally cool with it, will be totally okay with it, and no problem. This problem doesn't exist on the UI side because there is no exposed um, functionality. There's no exposure there. People can't just pass in an API. But this is just still debatable. I'm still thinking whether this is a legitimate case or not. So we'll think about that. We'll think a little bit about that. So I'm going to skip the gender for now, but I might come back to it in the next sprint, in the next video, and tell you probably we need to validate this. So this is one part. The other part here that we have a bunch of dates, and I see two GUIDs, created by and updated by. Since we already done the GUIDs validation on the ID, let's leverage that existing test then. This test in here that says if the ID is invalid and all that kind of stuff. Let's do this. Let's have this test in here. And this will say, instead of student ID, if created by ID is invalid. And here we go. Created by, this is a GUID for the creator of the record. That would be the user mainly, the logged in user, or the student. And this is an invalid ID. And instead of ID, we want to put in created by and created by in here. This will blow up, obviously, because we don't validate created by. So let's just go ahead and validate created by. Why not? Here you go. And just, just out of curiosity, just doing your due diligence, we should probably validate these properties in the exact order they were defined in their original model. So I'm going to move this a little bit to the bottom. If that's okay with you, because we want to say, okay, if you have if you have a model of some sort, and this model has all of these properties like this, right? And every test is quite large. You don't want to go and say things like, well, let's just put the validation tests everywhere and let's go find them, right? Instead, if you put them in the right order, at least I know what to expect, where to look for a particular value. Obviously, some people will say you can always just go and use the find functionality. That's okay if you want to do that. I also am very big on keeping your code. I like to have some sort of a consistency and a little bit of art in your code. So if your model looks like that, then probably your validation should reflect that. So let's just do that. Let's go back here and say this is our created by. Did this guy fail? Let's make it fail first. Let's fail and then pass and do all that kind of good stuff. Here we go. So this guy's failing. It's failing for all the good reasons. So you told me that you're going to throw a validation exception, but you didn't. That's right. And let's just go here and say this is failing. And let's go back to our register in here, and let's just say it's invalid. See, it doesn't really take much effort. You're just adding in validation rules very easily and cleanly without any. I think it's created by. Yeah, created by. It would be nice, and I think the new functionality in Visual Studio, the ML functionality, using artificial intelligence, would tell you that you have some redundant information. Like you see these little 3 dots. Sometimes it's smart, sometimes it's really dumb, right? It's asking you to do things that are dumb. Like in here, do you see these little 3 dots under identity number? If I control period this, it says add argument name text, like this. This is not bad. This is not too bad. This is not dumb. This is actually all right. But do we need it? I'm a big proponent of, yeah, see, it's changing it from identity number to first name because it saw me doing first name before. So it's thinking, oh, that's redundant code that he's doing. So maybe I should just do whatever he's doing. Sometimes it's smart, sometimes it's not really that much. But definitely an alias is okay, especially if you're passing something interesting that needs to be clarified. But is invalid created by, I think it's good enough. You have to understand the rules so you know when to break it. So now we have created by. Let's go back to our test here and let's run it. Let's make sure it's passing. And then we're going to do the updated by. And then we're going to validate the dates and then we'll be done. That would be mainly what we're going for just for this video, just validating, structurally validating the input data. Here's this guy. Pass. And let's do another one for updated by. Some people might say, Hassan, okay, we get it. You know, nope, I want to put this on record so you get to see how everything is being done. So this is updated by. It's an invalid situation. Instead of created by, we're going to say updated by. Let's take this guy here. This is all I have to change. Let's make that test fail. Usually I try to keep my tests around 200 lines of code. Sometimes it'll push further. In that case, I really highly recommend you break it apart a little bit further, like IDs, validating dates, validating text, whatever the case may be. Okay, so this guy is failing. One more check. It's bad. You didn't throw the exception when you promised me to throw the exception. And then if I go back to the validation here, I get to just add this guy right here. And updated by, right? And this is updated by. One little mistake will make one of your tests freak out. And this is how you know you get to sleep at night knowing that your software is in good hands, right? Takes you a tiny bit of effort and a little bit of practice and building a little bit of experience, and then you get to make very, very good decisions on your own. So here we go. Boom. This guy's passing. Great. So this is the validation piece for this. Let's validate some dates. Shall we validate some dates? Let's validate some dates. So what's an invalid date? A date that's at its default value, and we're just going to keep it at that. You know, default value, when you say default value, if you look at your C# interactive, if you say you have date time offset x equal default. So what's really the value of x? What's the value of x? The value of x here would be the beginning of time. Can you actually assign null to date time offset? I don't know. Let's find out. Can I just say null? I don't think you can you? You can't. So if your date is at its default value with any other additional rules, then at this point, freak out. Start freaking out. So let's do this. It's going to be very simple. It's going to be very similar to the stuff that we already done. So let's just go here and say, from an order standpoint, we stopped at first name. We can just go here and say, give me this. And let's go here, validation exception on register if birth date, if date of birth, or birth date, let's birth date. Right, birth date, and then let's go here and say, is it, yeah, it's birth date, and this is, obviously it's not going to accept that because it's invalid. Date time offset, invalid date, there you go. Default, so this is invalid birth date, like this, and let's throw the exceptions. This is the date validations. Here we go. And this guy is freaking out because it said you should throw an exception and you didn't. So let's go ahead and add here a failing test. And let's go ahead and make that test pass. So where's my validation stuff? We might need a new method in here. And this method takes a date time offset date. And this is where we go and say, does this date equal, hold on, date equals default. You gotta love the fat arrow functionality, the functional realm that C# is taking. Alright, so first name, we're gonna put them in order, right? So it's still invalid. Let's just go in here and say student dot date of birth or birth date. And let's put that in there. All of this is good and dandy. Let's go back to our test and let's run our test. Here we go. Boom, the test is passing. And then there's two more of these that we want to validate, which is created date and updated date. Like I said, it's just structural. You're the UI, you know, it's not your job to do any logical validation. It's not your job to do any it's your job, however, to do dependency validation, and that's what we're going to talk about in the next video. That's what we're going to talk about in the next video. All right, so here's that. Let's see. All right. So this guy is done. Let's take this test again and do the created date and the updated date. So this is here, invalid date, created date, created date, and instead of birth date, we say if created date is invalid and log it async. This should make it happy. Let's go ahead in here and check this out. All right, so this guy is failing. Is it failing for the right reason? Yes, it is. Let's go here and say fail. And let's go back to our validation and add created date. So where does created date actually stand in the order of a student? Created date and updated date comes before created by and updated by. Fair enough. No problem. So that would be this guy. Here's all my rules. So this is created date. And let's go back to my test here and run that test. Here we go. And then the last test for this session is to validate the updated date. And because this is a again, a logical validation would be that the created date and updated date are the same. But what if you're doing, you know, migration of data? This is why we're not doing that at this level. So created date, it would be updated date, and updated date would be, oops, something like this: updated date, updated date. This is all good. And then this guy will fail gloriously because we want it to. Only engineers would understand this, that jumping super happy and being full of joy when something fails, because we know why it's failing, right? So this guy here is failing because the exception is here. Okay, great. Fail. And then the last line of code for us today is to take this created date guy in here and put it here and just say updated date. There we go. Updated date, updated date, updated date. Let's go back to our test. And this guy is passing. Put that guy in here. And please consider when you when you write your code, you probably want to think about, you know, how how you want to keep your code clean. There's this really nice thing that comes out of the box. If you go right click on the solution and then analyze code cleanup and select run code cleanup. I don't know why it's not going to show this. Let me pull that window here a little bit for you. Right click and then you go analyze code cleanup and then run code cleanup profile 1. I am usually very happy with the default stage of this. If you look at the exceptions, it basically you know, cleans up things for you. Let's see what it really cleaned up. Cleaned up something in here, I'm not sure. Yeah, it did. It just, if you have an additional space, you know, it just cleans up things for you. Okay, so So this is the test. Everything is good. I'm just going to do code cleanup. So this is done. That's one thing. And then the other thing you want just out of, this is software craftsmanship, right? You're trying to make sure things are clean. You're trying to make sure things are in good state. This is all the validations that we can think about for this. And with that, this basically is about the biggest piece that comes into play when you're building broker neighboring services. You want to know that your data is structurally clean. Let me press on that. Structurally clean if you're relying on an API, and structurally, logically, and as a dependency clean if you are the last point of contact before the storage resource. In the next video, we're going to talk a little bit about the other exceptions that happen. So these are just validation exceptions that we create. What about the exceptions that happens when you call the API? What if you get an API exception like, forbidden or unauthorized or URL not found? All of these things you want to account for when you're building production-ready software. You can't just build an end-to-end and say, okay, that's my software, it works, it's great. No, you have to account for all of these edge cases. You have to account for all the possibilities. You have to defensively program against all the possibilities. So there's dependency exceptions we're going to talk about in the next video very, very soon. I'm going to make sure I keep this series up to date. And then there was a service exception, which is very, very straightforward. A service, memory leakage, something happened, unexpected, a thread is out of control, or whatever the case may be. We want to be able to handle this as a safety net so we can encapsulate all of this. So there's dependency exception, there's dependency validation exceptions, and there's service exceptions, which I can't wait to tell you about because there's so much to share in building enterprise end-to-end Blazor applications. I thank you so much for watching, and if you have any questions at all, I will try my very best to answer your questions and as soon and as fast as possible. I'll even give you a heart emoji so you are excited about me just seeing your. I want to let you know that I saw your comment. Even if I can't answer it right away, I'll just put a heart emoji in there just so you get to know that I'm aware of your question. I'm going to try to answer it as soon as possible. And have any questions, drop it in there. I'll put some resources in the description. And don't forget to like and subscribe. Thank you so much for watching. Take care.